Now observe this case. In this, the solid is resting on its base on the HP and it is cut by a section plane perpendicular to HP and inclined to VP. When the section plane is perpendicular to HP, you have to represent the section plane with its horizontal trace. Now observe how I am sending the section plane. Okay, this is the position of the solid. It is a pentagonal pyramid. A, B, C. These corners are visible and D, E are invisible. This D, E I am representing with dashed lines. This is the apex. Now I will cut the solid with a section plane which is perpendicular to HP and inclined VP. You have to send the section plane such that it is perpendicular to HP. In the perpendicular direction only you have to send the section plane. This portion I have removed, which is in between the observer and section plane. This is the section obtained. Now in the front view I am not getting the true shape of this because section plane is inclined to VP. If the section plane is parallel to VP, you will get the true shape in the front view. But here section plane is inclined to VP. To get the true shape, you have to see the section in the perpendicular direction of the section. That means you have to take the auxiliary plane to get the true shape of the section. Now observe here. Now I am getting the true shape of the section when I am saying perpendicular to this section. That means while drawing you have to consider an auxiliary plane to get the true shape of this. In this problem, a pentagonal pyramid is resting on its base on the HP. When a pyramid is resting on its base on the HP, then we can understand that its axis is perpendicular to HP. According to our standard procedure, when the axis is perpendicular to HP, you will get the true shape and size of the base in the top view. So you have to start the problem from the top view, and from the top view you have to project the front view. Then projections of the solids part is completed. The next step will be representation of the section plane. First complete the projections of the solids part. To complete this, you take a XY line somewhere here. Somewhere here I am drawing the XY line. This is XY. Then I will draw the top view. I will draw the top view of the solid somewhere here. This is the top view. This is A, B, C, D, and this corner is E. Somewhere here I will get the apex. So this is OD, OA, OB, OC, and OE. Now from the top view you project the front view by drawing the projectors. Now I will draw a projector to the front view to get A dash. Somewhere here I will get A dash. Here I will get E dash. Somewhere here I will get D dash. This point is C dash. Here I will get B dash. I will extend this projector to 60 distance. Somewhere here I will get O dash. This is the axis distance, axis height 60. This is the slant edge O dash B dash in the front view. And this is the another slant edge O dash A dash. O dash E dash is invisible. I will represent that with a dashed line. O dash C dash is visible. That will be like this. O dash D dash is again invisible. That I will represent with dashed line. This is the base. Now projections of the solids part is completed. Now the second step is representation of the section plane. Now section plane is represented something like this. Section plane is perpendicular to HP and it is inclined 45 degrees to VP and it is at a distance of 8 mm from the axis. So here what you have to do is first draw a 45 degree line somewhere here. Draw a 45 degree line. Align your mini drafter. Align your mini drafter to this. Then using this scale you take 8 mm distance somewhere here. Now mini diopter is at an angle of 45 degrees. Move the mini diopter to this point. Using this scale you take 8 mm distance, something like this. Then draw the cutting plane or section plane like this, and represent the section plane with its horizontal trace because it is perpendicular to HP. Now this is the section plane. After drawing the section plane, you have to identify the cutting points. So you move from left hand side to right hand side like this and give the names for visible cutting points. Now I am moving from here and I am moving like this, left to right. Here this cutting plane is cutting the base edge AB. That means this is the first intersection point here. You call this as some 1. Next it is cutting this slant edge OB. That is 2. Next it is cutting this slant edge OC. This point is 3. Next this section plane is cutting this base edge CD. This is 4. Now all are visible. Now I will move in the opposite direction. Invisible edges are not there. While I am moving the opposite direction, I have to identify the invisible edges, cutting points with respect to invisible edges. So here in this problem, invisible edges are not there. So I am not getting any points in the opposite direction. Now I will mark the point details here. AB. On AB edge I am getting 1. Next point 2 is on OB. Point 3 is on OC. Point 4 is on CD. Now when I am transmitting to the front view, I have to get all these points. Okay. Now 1 point I will transfer to the front view by drawing a projector. Somewhere here I will get 1 dash. 2 point, when I am drawing the projector, that projector is overlapping with this. Slant edge. So you transfer this to the adjacent point, adjacent slant edge, that is OA. Somewhere here I will get that point. From now this point is on OA. So you draw a projector onto O dash A dash, something like this. Here you will get the point which is on OA. Now you have to shift this point onto the correct generator, correct slant edge, that is O dash B dash, or required slant edge, that is O dash B dash. Now you got 2 dash. Okay. Now next point 3. 3 is on OC. So you draw a projector. Directly you are getting the intersection point on O dash and C dash. This is 3 dash. Now observe, third point you have to get on OC. That means in the front view O dash and C dash. Fourth point is on CD. CD is on the base. So somewhere here you will get the fourth intersection point. Here you will get the fourth point. This is 4 dash. Okay. Now you got the section in the front view. But as the section plane is inclined to VP, you are not getting the true shape, but you are getting the apparent section of the apparent section in the front view. Now this is the section in the front view. Now this is the portion of the solid which we will retain. This portion we will remove. That portion I will represent with the hatching 45 degree inclined lines with the uniform gap like this. This is the section, apparent section in the front view. Now what you have to do is, you have to draw the true shape of the section. In the top view, this part I will retain. This part I will remove. Okay. Now you take a auxiliary plane somewhere here. Somewhere here I will take the auxiliary plane x1 by 1. I will draw the projectors. From 1 I will draw one projector. From 2 I will draw one projector. From 3 I will draw one projector. From 4 I will draw one projector. Okay, now I want to get point 1 on the with respect to x1 y1. So here you are drawing from the top view, so you have to take the distances from the front view. Here I am going to get the true shape of the shape which is in the front view. That's why you have to take distances from the distance of the front view points with respect to xy. That means distance of 1 dash from xy is 0 because that is lying on the xy. So you just move to point 1. From there you move like this. Automatically here you will get point 1. Now take the distance of 2 dash. This is the distance of 2 dash. In the front view you take this distance with compass. You move to point 2. Then you move like this. From here mark the distance. Somewhere here you will get it. That is 2. Take the distance of 3. Move to top view. From there you travel like this. Then draw the arc. That you will get somewhere here. This is 3. Fourth point is again on the xy line. That means somewhere here only you will get 4. Now join 1, 2, 3 and 4. These points you join like this. This will represent the true shape of the section. Again you apply hatching to this true shape. That means draw 45-degree inclined lines with uniform gap like this. Okay.